Hello guys, I'm back. The previous video we set up some aim offset for the enemy character's face. We're going to set it up in the animation blueprint. Now we're going to start by creating some variables. Now we're going to need some vector math in here to so if our player is standing in that corner, then we need to get a vector from in the direction of the player and our current forward vector, and we need to find out what's the rotation, and based on that we're gonna give the values for face pitch and face yaw. I'm just gonna drag off the animation update and we're gonna start our work here. Yeah, so yeah. So yeah, we've got the aim offset AO over here, and we'll just promote these two into variables, yaw and pitch. I'm just gonna delete these. Let's do it again. Yeah. So I've already got some variables created for those. Face yaw and face pitch. As we did in the last video, we set up the aim offset to have the player, Sevarog, look around in different directions based on what values we provide in there. So we need a base pose over which we're going to do the face aim offset. So I guess it's safe to say we can just skip this part and apply it straight onto the final pose, because at the end us wanting Sevarog to look at the player is the final additive effect, which is kind of independent of whatever previous state he's in. We want him to be looking at the player when he fires his attacks. So yeah, with that in place, we're gonna need to do some 3D math over here, vector math. So I just pulled off another exit node from update animation, and we're gonna just get my character. I guess doing Sevarog is much simpler. Yeah, Sevarog, get actor location. So yeah, let me show you what I'm trying to do. So this is Sevarog. He's looking this way. These are our two axes. And this is the player, P. Now what we want to do is we need to get this vector, which is originally position Sevarog, position player minus position Sevarog equals this vector. So yeah, that gives us this vector. and this is the character. Our character is forward vector, so we just need to find the delta rotation between these two, which would give us those two values for pitch. So if Sevarog is standing tall and our player is like this on ground, Sevarog has to look down, which gives us the pitch value. And this, if we say, is his forward vector axis, local axis, and this is the player character, then this vector gives us the yaw. So that now that math is clear, let's get down to business. Get target character, get actor location. We're gonna do vector minus vector. So target minus my location. That gives us the direction vector for Sevarog's. Yeah, I mean from Sevarog to the player character. Yeah. Now we need to get actor forward vector. So that's our another reference. With this we need it normally. Yeah. Now what normalize, I guess you all should know what normalize is that if you have a vector of magnitude, let's say it's not 1, and you make it 1, so there's no weights attached to it. For example, this is a direction vector and this is now a direction vector. If this in case is bigger magnitude than this one, then you're gonna have a lot more weight on this, so our other direction vector would have negligent effect on giving you a calculated value for whatever you're doing. So to keep things clean, we're just gonna normalize everything. I mean, not everything. We know that this minus this is not going to be a unit vector, so we're just going to make. Is there? Nah, there's no get unit vector. So yeah, there you go. Now, there's this one really useful function in Unreal. Fine look at rotation. Now, when it says it has to like accept start location and end location, and it would give the absolute rotator for that point. Let's say it's going to be like this. So this is your world 0, this is y, and this is x. If you have some object over here and you just give the start position and the end position, it's going to give you a you've seen one of those things, right? Rotators, which give you red, blue, green, which allow you to rotate an object around. So yeah, it's gonna give the yaw delta rotator for this absolute value from whatever axis it thinks is default. I think X is forward in this in Unreal. So yeah, with that in mind, I figured we could do some alternate kind of usage for fine look at rotation. So instead I'm gonna give it direction vectors. So I'm just gonna give it, oh, I need to stop closing the application. Damn. Yeah, instead of like giving locations, I'm gonna give it 2 direction vectors, and I'm gonna see if it gives me the delta rotator between them. So I'm just gonna give forward vector for start and the direction vector for the end, and let's see if it gives us something meaningful. I'm pretty sure it will. So we're just gonna set this to 0 because we don't want it to repeat. itself every frame. So yeah, when I hit play, yeah, as you see on the top left corner, it gives you the delta rotator value, and yeah, I'd say it's pretty clean. Is it? No, I don't think it is. We missed something over here. So yeah, let's just go ahead and try removing the normalize and see if that makes a difference. If yes, then my understanding of fine look at rotation is a bit off. So yeah, I think that this one makes a lot of sense. If you can see the pitch value, it's kind of like really relatable, because if we jump, we need to go a bit in the positive direction. And the yaw doesn't change at all. Yeah, that's pretty cool. So there should be some point where the yaw is like 0. That is like where the character would originally be looking. Now that's kind of like inaccurate in this case, because we want him to be looking at us, which is kind of like, I'd say it's 90-degree offset to what we really want. So this should be like 90. Yeah. So if my that guess, that little math problem was pretty accurate, so we just go ahead and combine rotators, and I see this gives you X, Y, and Z. I don't really know what those are. So if you expand, yeah, now you know that Z is yaw. So you're just going to do -90 and attach, and let's give it a go. You see, now that makes a whole lot of sense, because now we're standing right in front of Sevarog, and yeah, it should be -90. This is the front. So yeah, as you see, we're getting this LMBP error, which says our target character is null. Now, if you've done a little engine programming before, you know that there are different systems. So animation comes under one of those systems, just like physics, or I have a lot of ideas coming in my mind, but yeah. So I'd say animation blueprints run on a separate thread, which is why if your target character gets deleted first, Sevarog's animation BP is still running, and it's going to like try to update animation, and it'll get null over here because there's no target character. So it's not possible to delete like multiple threads at the same time, because you'd want to like cleanly wait for each of them to finish to like get out of the play state without having memory leaks and stuff. So yeah, we to solve this, we can simply have an isValid check over here, and that's going to take care of the error that we're having. Yeah, just keep things clean. I'm just gonna drag target character again. We're just gonna push these things aside, and yeah, now it makes things a lot cleaner. We don't need that reroute node. If target character exists, we just do that. Yeah, no errors. Now let's go to the anim graph, and yeah, finally we had this aim offset set up, so we're just going to set those values that we got from fine look at rotation. face yaw, face pitch. Yeah, that should take care of everything. Let's go. Let's find out. Yeah, he is looking at us. It's too dark to tell. You can kind of see. Let me put these two windows away. Yeah. Oh! As you saw, it kind of glitches. So yeah. If you know lerp or what lerping is, we can. One way to do it would be we'll have to like lerp these values to the target value. Now, one good thing of using aim offsets is that aim offset takes care of its own lerping logic, so you don't need to worry about all that math for now. So we're just gonna do lerp like interpolation speed, and we can set it to 1 for now. It's just a test value. Let's go ahead and see if that changed anything. If anything, the character should move his body slowly. Yeah, as you see, that had a very good effect. Now if you're somewhere close to human or superhuman strength, then you'll be able to do that at twice the speed, which should be believable. Yeah, so if you see that that is kind of really close to what we want, so 1.5, I'll just go with that value for now. And there you go, guys. That's aim offset. Look at player in action. We're on our way to making this character really horrifying. So yeah, see you guys in the next video. Hope you enjoyed. Like, comment and subscribe. See you later.